In this lesson, we will be finding the sums of fractions and mixed numbers with like denominators. So let's take a look at the first problem here. We had 2/5 plus 1/5. So let's try to understand the problem before we actually end up just coming up with an answer. Let's take a look at 2/5 and what does 2/5 represent? Well, if I have 2/5, what I have is starting with a bar. And inside that bar, I'm dividing it into 5 sections. So I got 1, 2, 3, 4, 5. So I've got 5 sections in here. So 2/5 would be 2 of these fifths filled in. So I have 3/5 remaining. So that's 2/5. Now I want 1/5. Well, I have the same size bar with these parts. Again, I'm dividing it into fifths. So I'm breaking this bar up into 5 equal parts. And all I am going to fill in is the part. So what we have here is on the top of the fraction represents the part. And so it's just a part of a whole. The 5 represents a whole. So there's 5 whole parts that make up 1. And over here we just have 1 part filled in. And so when I'm adding fractions, I'm counting up the number of parts. The whole is going to stay the same. We still are dealing with fifths, but we're just counting up how many fifths we have. So here we have 2/5. Here we have 1/5. So I have 2 out of 5. Here I have 1 out of 5. And so our total is going to be 2 plus 1, which would make 3 out of 5. And to show that, what I can do is draw another bar, dividing it into the same number of sections, and then showing that. See, again, I have these 2/5, and then I added on 1/5, and that made a total of 3 out of 5 pieces filled in. So that would be our answer, 3/5. Well, we can do another problem, very similar problem, just different values, and this time instead of 1/5 or 2/5, we're dealing in fourths. So we have the same size bar. The bar is the same. The difference is the number of parts. Here we only have 4 parts. We have the same bar, just 4 parts. Well, 1/4 would be just 1 out of 4 parts filled in. So we have another fourth that we need to add together. So I draw another bar, same size. The size doesn't change. Parts are the same size, but we look at the number of parts here, and it's the same, just 1/4. So here I have 1/4. Here I have 1 out of 4 parts. And together, all together, how many parts would that end up being? Well, what that would be is 2 out of 4. So let's draw that picture. So if I draw this picture, I would have the same size bar, the same size number of parts, but the parts, we've got 1/4 and 1/4, we said made 2/4. Now let's try to reduce this fraction. Look at this bar here. If I cut it right here, there's 2 parts here and 2 parts here. So we can divide this into 2 separate parts here. This being one whole part and this being another part. And what that would represent is just 1/2. This would be 1/2 and this would be 1/2. So what we did to get 1/2 is we simplified it by taking out the common factor. So we have the number 2 out of 4. That's what we got when we added 1/4 and 1/4. So what we're doing is we're dividing each of these numbers by 2. And when we do that, we end up with our answer, 1 out of 2. That would be it, 1/2. And that's what this represents. This is one whole, or one part. This is the other part that's not being taken up. So we have 1 part out of 2 parts total. Well, now we have 2 and 1/8. So what does that represent? Well, if we have 2, that represents that we have the same size bar, but it's all filled in. The bar is completely filled in. And we have another bar, and this bar is completely filled in. But here we have 1/8. So what that represents is just 1 out of 8 parts. So we've got to draw 7 lines here. 1, 2, 3, 4, 5, 6, oh, I'm running out of room here, 7. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8. 8 parts there. So 1/8 would represent 1 out of 8 parts. So there is 1, 2, and 1/8. So 2 and 1/8. Well, I'm adding 3, or I'm adding 1 and 3/8. So I've got that 1 whole part. So we'll start with this part here, which is of 1 whole. So the whole thing's filled in, doesn't matter how many parts there are. But then here we only have 3 out of 8 parts. So I draw those lines, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 parts. Okay, so there it is. So now we have 3 parts filled in. So we're going to go ahead and fill in that 1, the 2, and the 3. And so what we have all together is 1, 2, 3, 4/8. So when we count that up, 4/8 is what we have. So when we add these fractions, let me go ahead and rewrite this, 2 and 1/8 plus 1 and 3/8, we're adding up the whole numbers because we have 1, 2, 3. So we counted up all those whole numbers, so we have 3 here. And then we count up the number of eighths. We have 1/8 and 3/8 makes 4/8. 4 out of 8 parts are filled in. You can see that. But we need to reduce that. See, that fraction can be reduced. There's a common factor on the top. So we can divide this by 4, and I can divide this number by 4, and I'd end up with a 1 out of 2. See, 4 divided by 4 makes 1. 8 divided by 4 makes 2. So we could rewrite that answer as 3 and 1 over 2. 3 and 1/2. Well, we'll try that on these other problems here. So what we're doing is we can treat this as 4 wholes. So 4 and then 2 parts out of 7 parts. Over here we have 2 parts, or 2 wholes, and then we have 3 parts out of 7 parts. And we're just adding those numbers together. And so when we do this, remember you have 4 and 2. We add the whole numbers. It's just like having 4 bars and 2 bars makes 6 whole bars. And then we count up the parts. Here we have 2/7 and 3/7. So 2 and 3 make 5, but the number of parts stays the same. 7 parts, so 6 and 5/7. And that's reduced. 5 and 7 have no common factors. Well, over here, there's no whole numbers to add up. So we have no numbers to start by adding, so we're just adding the fractions. This is 1 out of 8 parts, 2 out of 8 parts. So 1 plus 2 makes 3. So I added these two numbers together, the 1 and the 2. That's how I'm getting this 3 right there. And then the parts, the number of parts in those bars stayed the same. That's why it's always over that same number, 8. So 3/8. So again, just to show you a visual of what that looks like, you have your bar, and we divide it into 8 parts. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 parts. So I can erase a portion of that. And then I can make the next one. So the same sort of thing. And so I can make another bar. And I'll have the same number of parts. So again, when we're doing this, the bar size is the same, the part size is the same. The difference is the number of parts that are filled in. So we've got our 8 parts there, and then we fill in, we got 1 out of 8 would be this one here. 2 out of 8 would be this one and this one. So when we add this together, all we are doing is we're keeping the number of parts the same, bar size is the same. The difference is that we are filling in a different number of parts. So let's go ahead and fill in what we've got. We've got 1/8 and 2/8. So that's 1/8 and then 2/8 makes 3 out of 8 total parts. So 3/8. Well, one more problem to try. We got 1 3/10. So 1 3/10. Let's see if we can do this without the bars. So 1 whole and 3 wholes. So that's 3 bars and 1 bar altogether makes 4 bars. And then we count up how many parts. Remember over here we had 1 part and here we had 2 parts. Well, here we have 3 parts and we have 2 parts. So we're adding those numbers together and we get 5 parts altogether out of a total of 10 parts. But we're not done yet. We have to reduce if possible. So like here we could not reduce. 3 and 8 had no common factors, but here we can. We can take out a common factor. See, 5 can be reduced by dividing by 5. 10 also has that common factor of 5. And so when we do that reducing, we end up with 1 over 2. So our answer is 4, so I bring down this 4, and 1/2. And that would be our answer. So those are some of the problems that you'll see on tonight's homework. Good luck.